Alright, so now we're going to look at some nomenclature questions. We start with a bicyclic molecule, and remember this is a bicyclic molecule because it would require us to break two carbon-carbon bonds in order for it to be an acyclic molecule. The second thing we need here are the lengths of our bridges. So we identify the bridgehead carbons as being the two carbons where all of the rings sort of come together. Then we count the number of carbons in each of the bridges. So we have one here that's 2 carbons in length. We don't count the bridgehead carbons themselves. Up here we have another 2 carbon bridge. And over here we have a 4 carbon bridge. So we put those numbers from highest to lowest, 4, 2, 2. And then we count the total number of carbons in the ring. And by ring we mean all the rings of the bicyclic system. We can see that there's 10, so this makes this bicyclo 422 decane. Now in part B we have a cycloalkene, and we can see clearly that there's 7 carbons in this ring, as well as 2 alkenes. So we're going to have cyclohepta, and then for the 2 alkenes, diene. But where do we start? Well, we always start with the alkenes. Remember that alkenes always get priority in naming over any substituents that might be present. Now, once we get through both of those, then if things are the same, we would use the substituents to break the tie. But we need to start with this alkene here because it has substituents on it. And we can get the same numbering whether we go from this alkene or from this alkene. We get 1 for the first carbon of the first alkene and 4 for the second one. Now, which way do we go? So if we start with 1 here, then we have to go this way because we have to go through both carbons of the alkene. So this, if we do that, the second alkene would start at carbon 5. But if we put 1 here and go this way, then our second alkene would start at carbon 4. And since that's a lower number for the second alkene, that's what we use, is 1, 4. From there, we need to name our substituents. We have a bromine at carbon 7. So 7 bromo. And then we have a series of methyl groups at 1, 2, 3, 6, and 6. Since there's 5 of them, we'd call it pentamethyl. The next thing we need to do is to name our stereocenters. Now, normally in a problem like this, we would need to define each of the alkenes as E and Z. But with a ring this small, the alkenes can only go in one direction. So if you look at the key, you'll see they're both labeled as Z. That's not something you'd have to do on a question like this, though. Once your ring gets up to 9 or 10 carbons, though, at that point, yes, you do need to still indicate the alkenes as E and Z. But for smaller rings, 7 carbons and less, the ring is not able to adopt the other conformation, and so you would only need to do R and S here. So we have 2 stereocenters in this molecule. And I'm going to erase these other markings just so that we can see better what we're looking at. We have a stereocenter at carbon 3 where the methyl group is, and we have a stereocenter at carbon 7 where the bromine is. So for the bromine, carbon 7, the bromine is going to be highest priority, higher atomic number than either of the other two carbons. Now this carbon, because of the double bond, counts as a carbon bonded to 3 carbons, as is this. If we go 1 carbon further, we now have an alkene, again, that has an extra methyl group compared to this alkene here. So that makes this 2 and this 3. Again, why is that? Well, this is a carbon that's only attached to other carbons. This carbon is attached to a hydrogen. So our arrow here goes clockwise, which would make it R, but our lowest priority substituent, the hydrogen, is pointing forward, so we take the opposite, which is S. We also have a second stereocenter. That's the one here at 3. Now here the hydrogen is already pointing back. The methyl is going to be third priority. And then we have an alkene carbon with a methyl group versus an alkene with a hydrogen. That methyl will make it higher priority to the right. We go counterclockwise, which is also S. So we have 3S, 7S. Again, you could do the E and Z nomenclature as well. If you did that, you would get 1Z and 4Z, but because this is within a ring, we don't need that here. Finally, in part C, we have another compound that has alkenes. This one also has alkynes. Now, we know, fortunately, again, that we need to start at the end of the chain closest to where the alkene or alkyne is. And that would be over here. Here, the alkene starts on the first carbon. If we started at the other end of the molecule, then we would not get an alkene or an alkyne until the third carbon. So we have a 10 carbon chain here. So this is a decane. There's 3 alkenes. They start at 1, 3, and 5. So this is 1, 3, 5 triene. And we have an alkyne at carbon 7. Our next step is that we need to name each of our substituents. So let's list them. At carbon 1, we have 2 fluorines. Methyls are at 2, 3, and there's also 2 methyls at 9. So that is, of course, tetramethyl. 4 has a bromine. 5 has a chlorine. And 6 has an ethyl. So we will need to alphabetize those. Before we do that, though, let's take care of any stereochemistry. So first of all, there are no chiral centers in this molecule, so we don't have to worry about R and S. What about E and Z? Well, our first alkene, the one that starts at carbon 1, has 2 identical substituents on the same side of the alkene. Because of that, it wouldn't have any isomers. We don't have to define it as E or Z. The second alkene, is here. On the right side, we have a bromine, which is higher priority than carbon. On the left side, we have a methyl, which is lower priority than the alkene. So we can see that the higher priority substituents for carbon 3, or the alkene that begins at carbon 3, are on the same side. So we have 3Z. Now let me erase those so we can look at the last alkene. At carbon 5, we have chlorine, which is higher atomic number than carbon. On the other side, we have a CH2 that's bonded to 1 carbon versus a carbon that's bonded to 3 carbons. So higher priority here versus here. Again, on the same side, so 5 is also Z. So now we need to put all of this together. Any stereochemical descriptors go out in front, 3Z, 5Z. Then we put our substituents in alphabetical order. 4 bromo, 5 chloro, 6 ethyl, 1 difluoro, 2 3 9 9, tetramethyl, deca 1 3 5, triene 7 ine.